today's question is question number 4 from continuity and differentiability, exercise 5.1. So the question is, prove that the function f of x is equals to x power n is continuous at x is equals to n, where n is a positive integer. So here we need to prove f of x, this function x power n is positive integer at this point. The point is n. So I already explained the formula. Again I will write here. F of x is continuous at x equals to c if limit extends to n c, limit extends to c, f of x is equals to f of c. So this is the general formula. Now I will apply this formula here in the given function. The function is f of x is equals to x power n. So I will write this function in this formula. And c, what is the c? They gave n. At x is equals to n means here the point is n. So I will write c value n. So here I will write function is f of x, that is x power n, and c is n. Now write in this formula, limit extends to c. What is c here? N. Limit extends to n, f of x equals to f of c. C, what is c? F of n. Now take LHS. What is LHS here? Limit extends to n, f of x is left hand side. I will take LHS is equals to limit extends to n, f of x. So it is left hand side. In this I will write what is f of x. The function they gave f of x is x power n. It is f of x. So I will write here limit extends to n, x power n. Now write this x value in this x place. Here I will write n in the x place. So x value here n. So n power n. I replace n in the x place. So it is LHS. LHS value I got n power n. Next take RHS. RHS is equals to, what is RHS here? F of c. So I will take f of c. So f of c means the given function in x variable. Now I will replace x by c. Put x is equals to c. Right here c in the x place. So that is c power n. Now what they gave c value? C value is n. So n power n. Both are equal. LHS and RHS both are equal. Therefore LHS is equals to RHS. Hence f is continuous. F is continuous at where it is continuous? At x equals to n. So this is the fourth question solution. Next, I hope you are understanding. If not, send a comment to this video under this video. Next, fifth question, is the function f defined by f of x equals to, they gave two cases. If x is less than or equals to 1, the function is x. If x greater than 1, the function is 5. So we need to prove these conditions continuous or not. at x equals to 0, at x is equals to 1, at x equals to 2. Now we are going to check. First we take at x is equals to 0. So I will take first case 1. At x is equals to 0. So when x is equals to 0, where is 0 in the case? When x less than 1. Less than 1 means 0 is less than 1 only. So at that time the function is x. So at x is equal to 0, the function is f of x is equals to, what is the function when it is 0? The function is x. So f of x is equals to x. Now if you observe, this is a polynomial function. X is a polynomial function. This is a polynomial function. When the function is polynomial, then it is continuous. Therefore, f is continuous at x equals to 0. So next, case 2. What is the case 2? At x equals to 1. So case 2 I will take at x equals to 1. At x equals to 1, the function is continuous or not. We are going to check. When x equals to 1, we will check the condition. So when x equals to 1, the function is x. So first I will write the formula. It is equal case. Exactly it is equal to 1. So, previously I told that when it is exactly equal to this value, the formula is LHL is equals to RHL is equals to f of 1. So LHL, left hand limit of this 1. 1 left hand limit means before 1 is 1 minus, after 1 is 1 plus. So before 1 I will write that is left hand limit. So left hand limit is LHL is equals to limit x tends to 1 minus. I will indicate minus in the power, means this value before 1, that is LHL, into f of x, that equals to, actually this tends to 1 minus, but I will select it from 0. It tends to from 0. So it starts from 0, that is h. I will change the variable also. H tends to 0 means it is from starting. We are going to start from the beginning. So h tends to 0 into f of, now this x is going to replace by 1 minus h. 1 minus h means 1 before value. LHL I told. So whatever it may be the value, I don't know, but we will take 1 minus. So that is LHL, 1 minus h. Now I will write the function. Limit h tends to 0 at x equals to 1. At x equals to 1, what is the function? The function is x. I will write x here. So in the x place, what is x here? 1 minus h. In the x place, I will write this x value. What is this x value? 1 minus h. So 1 minus h. Actually it is x. In the x place, this x value we will write. Okay, 1 minus h. Now write h value. Now write this h value in the h. So what is the h value here? The h value is here 0. The 0 value write in this h place. 1 minus 0. So this value is 1. Next. So LHL over. Now go for RHL. Now the RHL value what is RHL? Right hand side of this 1. They told at x equals to 1 means left hand side of 1 is 1 minus, right hand side of 1 is 1 plus. So this is limit x tends to 1 plus f of x. So that is limit, I will start from 0, h tends to 0, f of x is going to replace by, it is RHL means 1 plus h. At that time the function is, when it is equals to 1, what is the function? The function is, what we have, 1 plus 1 plus means what is the value? 1 plus means more than 1 is 5. So at that time the function is 5. When it is 1 plus more than 1 the function is 5. So I will write here the function 5. Now this value is 5 only. Now see, what is LHL value? LHL value is 1, but here RHL value is 5. Are they both equal? No. So LHL not equals to RHL. Therefore f is not continuous. F is not continuous at what point it is not continuous? At x equals to 1 it is not continuous. So it is not continuous at x equals to 1. So we finished at x equals to 0. At x equals to 0 it is continuous, and we finished at x equals to 1. So at this case we got not continuous. Next, at x equals to 2. This is the third case. At x equals to 2. At x equal to 2 means it is more than 1. The case is more than 1. More than 1, what is the function? The function is 5. So f of x is equals to 5. So 5, it is a constant. When it is constant, we call it as polynomial. So this is a polynomial function. This is a polynomial function. When it is polynomial, then the given function is continuous at the particular point. Therefore, f is continuous at x equals to 2. So at 3 cases, at x equals to 0 case, at x equals to 1 case, at x equal to 2 case, we solved this question. So what we got? At x equals to 0 case, we got it is continuous, means f is continuous. At x equals to 1 case, if it is not continuous. At the last, at x equals to 2, it is continuous. So today's questions are over. Tomorrow we will continue the next questions. Thank you.